Great. All right. So, how are this? How is your assignment with respect to that MapReduce going on? Are you stuck anywhere? Basically, the idea was to either code whatever five questions actually we solved yesterday, or just write a pseudocode, okay, step by step. That should be good. All right. Okay, so we are going to discuss further. Okay, Aruna is trying to set up Eclipse. All right, and all right, good, good. Okay, so till this point you set up Eclipse, you should be able to write the steps. I think you should. I think you can write the steps anyway, so it will be better to set up Eclipse. So should we take care of any version for Hadoop jars? That I'll explain today. I'll try to explain today if time permits. All right. Otherwise, those who want to step a little ahead, you can step a little ahead. I have set up an example for you. All right. So there is in the session number 5, in the session number not session number 5. Okay, session number 4, you can see that there is MapReduce testing. All right. So there is a project. There are two projects, one project and two projects. You can directly import these projects into Eclipse and see how are they working. All right. We will describe in detail as we go ahead. Okay. If you are a little impatient, you can step ahead and download these projects, import them into Eclipse, and test how are they working. All right. All right. And the course index, I mean, it's maintained by all of you. Here is the list. If you are interested in editing it, just request the access and I will keep on providing you the access. Okay. So Aruna's question is, can we use .NET for MapReduce? Not yet, not yet. But the the typical Java kind of a MapReduce, you can basically do MapReduce in two ways. One is writing in Java, other is streaming. Streaming streaming is what we are going to discuss today, and also we'll discuss Java thing today. And and afterwards, okay. So so using C#.NET, you can do MapReduce using streaming, meaning any program, any binary can be used in that case. All right. But even the HD Insights, what is HD Insights? HD Insights is the version of Hadoop that runs on Windows. Okay, but even HD Insights is nothing but Java code. Okay, so anyway, since Hadoop was in Java, it was possible to run it on Windows, but recently only everything has been made working, such as the various script, various process controllers, all those files have been made working now. And that means that even the HD Insights which is there, which is nothing but Hadoop on Windows, is essentially in Java. So even for that, you cannot write in C sharp right away, but you can use your C sharp exes as the Hadoop streaming. Okay, we will discuss it right away today. Today we are going to focus a lot on today's assignment is more about today's discussion is going to be very hands-on, and we are going to go step by step into that direction. All right. So yesterday we discussed that. So is everybody clear about this syntax? here what we are doing is, so yesterday, if so till yesterday what all we discussed was, okay, so Abhishek's question is that in the unusual democracy, I'll step back a bit. Okay, step back, not back, let me step forward. Okay, so Abhishek's question is, in unusual democracy, wouldn't reducer 1 only work if entire list 2 was present on every block of list on every node? So let me understand what you are trying to say. So what he's saying is that reducer 1, this is maybe this is the reducer you are talking about, will only work if the entire list 2 was present on every block of the list 1 on every node. Why do you think so? Okay, imagine this. You concatenate these two files and prepare a third list called list 3. You just concatenated them such that list 2 came above and list 1 is below. List 2 followed by list 1. Now, you in your map, you said that the first column is your key and second column is the value. And then Hadoop grouped this data together. All right. So if this file, these both files, list 1 and list 2 are existing or on multiple places, what will happen is, say, imagine this, imagine this. This exists on data node 1, all right? And this exists on data node 2, all right? So what will happen on data node 1? It will basically sort this data, put it in the output, and on the another data node this will get sorted, and it will put it in the output, and then both the outputs will get merged on the reducer, and this is what you will get. Right, did I make sense? So list 2 or list 1, list 2 does not have to be on every block of the list 1. Okay. Okay, so okay, should I just take this out? Let me demonstrate to you what is going to happen. Imagine this. Imagine this. We have we have these columns. Okay, there are too many tabs between, so don't bother about it. Imagine that there is data node 1 containing this, and data node 2 containing this, and data node 3 containing this. Okay, now on each data node the sorting will happen, so it will sort on each data node. Okay, and this will also get sorted, and this will also get sorted. Okay, now these, on the reducer node, what will happen is, on the reducer node these three files will go, and reducer will start comparing the first record of all of them. Okay, so it'll pick up whichever is smallest, which is, say, A is here, so it'll pick up A. Okay, these two records it will pick up, A and these two, right? Now, and also this one, also this one. Now it will, from the remit, both the lists. So this is how it's merging. Okay, this coupled with these two, it will pick up both of these records and create this, and C and C, it will merge both of, okay, and thereby D will come here, and then F. Make sense to you? So it has sorted the data. Now grouping is fairly easy. Now grouping is actually pretty simple, right? So all it needs to do is delete these, take it here, take it here, right? Similarly, delete this, take it here. So here you can go like this and here. Do you see this? All right. Now, so Aruna, is that clear now? Okay, good, good. Abhishek, it's clear to you also. Key value pair of A and B can go on different nodes. So no. So if the key is same, so no matter what happens, all the values for the same key will come on a single node, no matter how many reducers are there. If there are 50 reducers you have defined in while launching the program, you have said, I want 50 reducers, still, and there is only a single key in your whole input. If there is a single key in your whole input, all the values for that single key will come to a single reducer. Okay. So now you can imagine that if there are too many values for a key, if there are too many values for a key, then your reducers might get blasted. Okay, that's a flaw. And then we will also talk about, when we talk about combiner, how can we avoid those kind of problems. Okay. So let me take up Aruna's question. So Aruna's question is that, so feel free to ask the question. I know all of you would be having questions. Okay, the only way to get it cleared is by asking. Probably other people might be having the similar kind of questions. So Aruna's point is, so defining the key value pairs for input and output is the main crux of MapReduce to the most part. Yes. So first is defining the key and the value uh, as in the in-map phase. So most important part is probably figuring out how can we break our problem into a sorting problem, right? Like either way, word count problem could be solved using a hash table, in memory hash table, but we converted it into sorting problem by saying that if we sort our data by the word, then we can count the words easily. Correct? So that's the main crux. And second is how to aggregate values. That's something which comes automatically to all of us. Now, when we combine both lists, the actual header doesn't matter. One list has voter and votee, and second has voter and worth. No, actual header doesn't matter. Whatever you want to give it out, you give it out. Okay. You can also say that we will convert everything into strings rather than numbers, and then the life will be easier. Okay. Yeah, key and value would be different, right? Yes. Okay. So Seth's question is, can you move ahead with the example in the same way? Which example you want me to move ahead with, Seth? The word count one? So the key value would be different, right? So how do we get? Okay. So help me out, Seth. I'm actually a little lost. Which one are you asking me? So here is the new set of question. When we combine both lists, the actual header doesn't matter. One list has voter, this we have discussed. Can you move ahead with the example in the same way? Okay, which example? So Aruna is saying, so the key and value would be different. Yes. So how do we get the output that combine both the lists? So okay, all we need to do is in our program, we need to just tell that our input is not a single file but is a folder, and it will automatically concatenate the two lists. Okay, and in your map program, you will go through line by line, and then you will figure out how to represent the value. Okay, if you are using a programming language or non-streaming, you can mark the value that this is my integer and this is my value in the output itself. When we say key and the value, key always remain the voter name and value could be an object. Okay, and then while combining in the reduce phase, you can figure out based on the object definition. All right, and so how okay. So Saf is saying second step of mapper reducer. All right. So you mean to say this example or some other example? You mean this one? You mean this one? What is happening at this stage? Okay, I'll explain to you that. So okay, let me just change the column name for your benefit. And trust me, in the data file, the column headers are not there. Okay, if column headers are there, you can delete those. Okay. So I'm just changing it to make it a little more easier for all of you. So I've changed the name to voter here, voter here. I think that is the cause of concern. In list 1, voter has A. In list 2, person has A. How would it know what we mean the same thing as key? So see, this both the list if you concatenate like this, okay? If you concatenate like this, okay? Now when your program is reading each line, all it has to say is the first column is my key and value is 5. Okay, irrespective of what it is. So if you just imagine that both the lists are concatenated back to back, and then your program is being fed the whole file in a single shot, then how should your program behave? Then you will get the answer. Okay, yeah, so basically it's a tab separated file. This is also this is a tab, this is a tab. So the format is exactly same. A tab C, A tab 5. Okay. Now whether we mean, I mean, here we are not differentiating between whether it's a value or the string, but this reducer has to figure out when reducer, what reducer need to do is understand from the whole list which one is the number. Okay. It has to understand which one is the number, and then and which one is not the number. So B and C are not the number and 5 is the number, so it has to print B5 C5. So reducer has to do that here. Okay, so to your mapper command here, mapper command, you can imagine that the full line will come as input. The mapper will get full line as input. Your function mapper will get the full line, then it will split that line and figure out key value from that line and then output it. Okay, that should give you the idea. And here the reduce need to figure out which one is the number and accordingly print this kind of a result. Okay, so Saif, is it clear to you now, or should I explain again what has happened here? So all your program need to do is the reducer code. Code will get one line at a time, key and value at a time, and all it has to do is convert this. Okay, so this will be the key that reducer receives. Definition of my reducer is key and array of values, and all your reducer need to do is go through the values for value v in values, and first find out which one is the number. Okay, and then that becomes our worth. Okay, worth equals to none, and then if, so here it will say something like if v is number, then worth is your number, worth equals to v. Okay, and then break. And then once you're done with that, what you need to do is again you have to iterate over values. Okay, and say if v is not a number, I'm writing a very simple code, and then is not a then print print v comma worth. Okay, that's what it is doing. So for 5 and b, it'll become b5 c5 and so on. All right, so everybody is good with this? Seth, Aruna? All right, great. I'm moving ahead now. All right, so now we wanted to discuss few more things like streaming job. Okay, so rather than writing the code, we could use the commands like this. And yesterday we talked about SED. All SED does is replaces the space with new line. Okay, replaces the space with new line, and the reducer says user bin unique and C. All right. So SED replaces anything with something else, and unique says this. Okay. Unique basically counts the unique numbers and how many times they have occurred in a sorted data. All right. So the way it works is that it basically here when SED mapper is called on each line, it will convert that into one word per line. And this dashed line represents what Hadoop will do with your data. And then let me close my RStudio. All right. And also let me close other windows. It seems to be taking too much of memory. All right. And yeah, that's good. So I think that will take a less amount of effort now. Good. All right. So now Hadoop will sort your data. And here please note that the biggest difference between streaming and usual MapReduce is the data is not grouped. It's only sorted. Now, it's the duty of your command to group it. Okay. And that's all. Okay. Now you might be having a question that what if there are multiple reducers? So this is what is going to happen. Some of the keys are going to go to one, some of the keys are going to go to another, and some are going to go to third one. Now, the only guarantee it gives is that SA will always go to only one machine, meaning one key will go to only one machine. It would never happen that one key goes to multiple machines. Now, question is, how does uh, uh, say we used here these commands, which are standard commands. How does Hadoop detects that what is the key and what is the value? In what format this program which we are using, this program need to specify the key and the value. This program, all it needs to do is for each input, it needs to print key and the value separated by tab. Of course, this tab is configurable, but for arguments, for the discussion sake, the key and the values given by this program, whatever mapper are we using, has to have a separator by default, which is tab. Okay. Similarly, reducer need to understand how to handle key and the value when separated by a tab. Okay, and that's very important here. All right. Now, question from Basant is: Are the output of multiple reduced tasks finally grouped together before responding back to the client? This is a good question. This is a very good question. So let me put it here. Yeah. So a quick answer is capital no. Okay. So whenever if you remember our yesterday's discussion, okay, if you remember our yesterday's discussion, we talked about this kind of scenario, right? There were two files, part 0 and part 1. So effectively, multiple reduce phases create multiple files. All right. Now, the question always arises that just give me a second, Seth. So the question arises that how will I concatenate these two files? Okay, how will I concatenate these two files then? One way is just there is a Hadoop concatenate command which can basically concatenate two files. Also, please note that when you concatenate the result of two reducers, the overall output may not be sorted. Okay, may not be sorted. Reason being, the say there was a word called apple and there was another word called apricot in the word count case. So first apple might go to first reducer and apricot might go to the second one. So if there is another word called ball and there is another word called bat, so the chances are based on the hash function. So let's say apple, apricot, ball, and bat. Okay, so there is a reducer one. Okay, so it might happen that apple would go here, ball will go here, on the reducer 2, apricot and bat will go. Okay, so these are two reducer, which means there will be two files, part 2 and part 1. And when you concatenate them, you will get something like this, which means the result may not be sorted. Okay, for this you might have to figure out, you have to define something called a partitioner. Partitioners defines the criteria on which the keys are separated on multiple reducers. Partitioner decides that which key goes to which reducer, and that way we can get our results concatenated. Okay, in order. Yeah. So, Seth, do you want me to unmute you? Is that something urgent? Yeah. Okay. Okay. So yeah, if you have a question, feel free to write it. I can wait if you are writing a question. All right. Because what happens is that if generally there is so much of background noise, and if other people, multiple people start speaking simultaneously, it will be a difficult scenario. Okay. All right. Okay. So Saf says no, just let it be mute. All right. Okay. All right. Was I able to answer your question, Basant? Now moving on. Now let's try to run it. Okay. Let's try to run whatever we have coded. Okay. So here is our program. Okay. Let me again put it in my text editor to clean it up. So this basically, and in a Unix shell, if your program is spreading to the multiple lines, you can basically write slashes at the end of it, something like this. Okay. And yeah, okay, something like this. Okay. It essentially means everything in a single line. Okay. So I'm going to execute it as is, and we will debug these issues whatever we get. Okay. Is my font visible? You can see it clearly visible. All right. So if you run it, what will happen is it'll give an error saying the output folder already exists. So it says that the output directory already exists. Okay. So now we have to keep that in mind, that whenever we are doing any of this, you will get this error. And if you're planning a bigger project, you'll have to, and say every day you are running a job, then this folder has to be either deleted or renamed. So if the output folder already exists, we can delete it like this. Okay. So we can delete it like this. We are saying Hadoop fs rmr and then we are deleting. Okay. Be cautious with this command because it can wipe out the whole HDFS. All right. Now we are saying Hadoop jar, Hadoop streaming. We are telling Hadoop to run this streaming which understand remaining arguments. And remaining arguments are in minus input ascii slash word count slash input, and output is ascii word count and output, and we are running that. So it says that the folder already exists. This folder, doesn't it delete this? Hadoop fs minus rmr. Did we delete output folder, by the way? What did we delete? Yeah, we deleted this. All right. Now we say ascii. It should show all the folders in the word count case. And there are these many folders already in this. Okay. It does delete. It does delete. Even though it keeps on complaining. But if you see it's not there. Yeah, it's deleted. Good. Now let me try to run it again. All right. We are saying ascii word count and then we're putting data in there. Yeah, this time it's running. For some reason it did not run earlier. Okay. So what is it going to do? Let me try to tell you. So it's basically going to put the output in this particular folder. And also note that when the MapReduce starts, it gives us a URL to track the job. Even if we cancel the job, we press Ctrl C here, the job will keep running and we can track what's going on using this URL. Okay, using this URL, we can track what's going on. Let me mute myself. Okay, so on browser you can see that the status of the job running. Those who are inclined to debug and are doing print statements inside their map function, that goes into the logs here. Okay, it says that the task has succeeded. There are two tasks that are running here, and reduce also has succeeded, finished computation, and that means we can check in the hue. In the hue, if you go to HDFS, okay, if you see here, you can see there would be a sgiri folder. I can actually directly jump to sgiri slash output, sgiri slash word count and slash output, word count slash output. So it had just created, you can see the timestamp on this. You can see timestamp on this, and this is our single part, meaning there is a single reducer which was run, and therefore there is only one part. And this underscore success is a dummy file. It just tells us that the map reduce has finished. Okay, so it has generated the word count of each word. You can see that the blank has come so many times, blank has come so many times, and double quote has come so many times. And see, those words which are those characters which are attached to our words are not cleaned up. So do you see any problem with this? How would you want it to be? You would want it to be clubbed, right, together instead of having multiple. So we'll do that now. Okay, all right, so now let's say we want to clean up further. Let's say we want to say first replace space and tab with the new line, and then whatever is the output, you substitute non-alphabetic characters with this. Remove, if you have you gone through my regex class? No? Have you gone through my regular expressions class yet? If you have not gone through, then make sure you finish that class. Probably that will be very useful to you. So if you go into 30 May, on the session 1, there will be below recorded session, there will be a regular expression presentation and the class. It's 1.5 hour class, and this should give you a good enough confidence in regular expressions. Okay, and this will be your 1.5 hours, uh, worth spending. All right. All right. So now going back. All right. What was our input? Thank you, Dia, for clearing it up. Let me open another folder, another hue here. So our input here was the command which we were running. You see the command, we were saying input was a folder. The input is basically all the novels of Sherlock Holmes concatenated together. Okay. So in word count slash input, you will see multiple files. Okay, so you can see there is one file right now, but you can put multiple files here. And in this, it's nothing but all the books I've taken of Sherlock Holmes and concatenated together and put it in here. That is our input right now. Okay, And the volume is quite low here. Okay, the volume is around how much? The volume is around 2 MB, I think. Okay, S- uh, 6 MB. You can increase it to 600 MB. Still, the time taken will be fairly small. All right, so everybody on the same page. Now, next step is, so we saw that our output is not clean enough. So you can see that this is our word, one word. Okay. So streaming is not that streaming. Here we are saying streaming means streaming is a little bit of a misnomer here. Streaming does not mean video streaming or stream processing. Streaming it streaming means we are running our data through a program, and the program here is SED and unique. So we are running our data through these programs, and that's what is called streaming job. Okay. So yeah, that I should have cleared it up because the word streaming has been badly abused everywhere in whole computing. So starting with video streaming from YouTube, stream processing, and running a program through running the data through a program, everything is called streaming. Okay, so now let's clean it up. So what do you suggest for cleaning it up? So, which means our key value pairs were not clean enough. Let's clean them up a little bit more. So to clean it up, we are creating another script, okay, in which we are writing these kind of things. First is replace. I will show you this. So let's say we say echo, echo. This is some program which has weird characters everywhere. Okay. So this is not even running for me. Okay, now you can see that this is some program which has these characters. Now first step would be, first let's replace these characters with space. Okay, or let's just convert it into, let's just convert it into one word per line, which is going to give us this. You see this? Now we need to clean up all these lines. Okay, or maybe we can replace, first, we can say remove non alphanumeric character. This means not of A to J, Z and 0 to 9, which means remove all non alphanumeric characters, replace it with, let's say, space. Okay, now we have removed all the, we have cleaned up our line. Okay, but here you see capital S, or let me just try to do, this is some program which has this some characters. I'm just writing some crap, so don't worry about that. Now what we are trying to do here is we have just cleaned up all these special characters, okay, and replace them with space. And next step is to convert the white space into new line. Now you can see that, okay. Also we can put slash n here, and you'll get these kind of things. Now you can see the data is little clean, but we need to translate capital letters into small letters. So tr is a command of Unix which basically translate everything into one form to another. Okay, so using simple Unix commands, we are able to clean up our data such that there is one clean word per line in the lowercase. Okay, now we can take this command, whatever we have written just now, this full command, and put it inside this one script. Say, let me go to as Giri folder, my own folder, and my cmd.sh is there, right? Now here what I can do is I can basically comment out the previous line and put a new line here like this. Okay, and also note -r. Okay, -r is for applying the regular expression. Okay, that's it. Now you can see that if I have to do the same thing whatever I was doing earlier using a single command, now I can do it using this mycmd command. All right. Yeah. Let me fix my. Oh, I have not copied it properly. Now you can see that. So my cmd.sh has become a new composite program of other programs and is doing this job. Okay. So now if I have to use this kind of my program with streaming, so we'll have to ship this program to all the nodes, right? Because earlier, whatever commands we were running, SCD or unique, they were there already on all data nodes. If we do not ship mycmd.sh, it will keep on giving an error. Okay. So thankfully, Hadoop comes up with a option called -files at the end. You can see that -files at the end. Okay. All right. So here is my output 30 May. Okay. So now here you can see that instead of using cd command, this time I'm using mycmd.sh. Any doubts at this point? Sorry. Okay, so it says some error. Let's read the error. It says unrecognized option called -files. Let's try with -file. Okay. So the irony is it says it keeps me giving me warning that this is deprecated, use something else, but the new one options are not available. Okay, so maybe I need to install a little bit more. So Vikas's question is, in case of a usual Java MapReduce, not the this one, do we need to ship? So automatically whenever we say Hadoop jar, it actually ships that jar on all machines. But in case you have other libraries which your jar is referring, those libraries you will have to ship. Okay? Say your program is trying to send emails like every other program. Okay. Any questions at this point? So you can see that this is running, and whenever we this is, and also note few things here. We are saying that map task reduce tasks are two, which means there are going to be two reducers. Okay, there are going to be two reducers, which means there are going to be two parts in the output folder. Okay, till the point it finishes, let's go and check our word count. Output 30 May. You can see that this is, so it has already finished. Now I think it has finished. Yeah, and you can see that it has created two parts. All right, I'll open these two parts and let's pick up these first 10 lines. This is from my, this is my part 1. Okay, Let me just leave it the way it is. Okay. So you can see that this is my part one from first reducer. Now second reducer, let me have a look. This is the output of the second reducer, and the data is looks like this. Okay. Now important part here which I want to show all of you is this. So this is the count. Okay, unique minus c. When we run unique minus c, it displays the count first and then the value, then the key, and therefore, and you can see that now you can see that if you concatenate these two values, they may not be in the sequence. Okay, so 003 went to first reducer, while 0 went to the second one, 0001 went to the first reducer, 00 went to the second one, 0012 went to the first reducer, 00 went to the second one, and so on. You can see that clearly. Okay. Individually, both parts are sorted. This is our key and these are the counts. Okay, because why counts are before than the key? Because unique prints it that way. Unique prints it that way, and that is why we see this way. Okay, and here there is some blank line, blank character, or I think it's a new line character or some other character which has occurred these many times. All right, sounds good to you? Now the other question is that the timestamp of the server? You mean the on the file when we are running it? This one? Yeah, this is the timestamp of the creation time of. Yeah, that's what I'm talking about. So this is our output folder, and these are part 0, part 1, and then there is a creation date and creation time. In here also, in the output folder, you see the same thing. Is this the one you're talking about? So this timestamp is of server, of course, because we are just submitting it and that's all. Everything is being done by the column date in the file. Okay. All right. Now, is the value being converted into hex? Which value are we talking about? No, no, no. These are the actual values that are existing in that big txt dot. Okay. I will open this file for you. Big.txt. Okay. This file is existing here. I can open it with my text editor. It's not that big a deal. And here you can see 000, and you will find that somewhere at least. Where is it? Yeah, there are those. So this actually was broken into two, and that is why you see that. Okay, because comma has been replaced by space, and that's all. Okay, we can do further smart things such that we take care of these words properly. Okay, so that will involve a lot of processing, and that will involve a little bit more smartness than what we have done. All right, good. So everybody comfortable with this streaming thing? Great, great. Moving ahead. So this was one. The important part here, there we did two things. One, we mentioned the number of reduced tasks we want to do. If we mention 3 or we mention 10, there will be output 10 files. But at the same time, They will be basically running on using these four data nodes. Okay, this is my file. All right, so okay, so hands-on is done. So okay, again, the way we define streaming is, let's just uh, think about streaming as something else. Okay, so what does it mean by Hadoop streaming? Hadoop streaming means using your existing binaries for MapReduce. Using your existing binaries for MapReduce. It's as simple as that. Instead of writing code, you are using your binaries for MapReduce. Okay. Also, you can combine and say that your mapper is a binary and your reducer is a Java program. You can do that. You can combine mapper and reducer that way. Okay. No. So Seth, it doesn't mean that way. It's just that when it has sorted the data has numbers first, and then if you go to the last block, you will see the other words. Make sense to you now? Okay. Now, the one thing I wanted to express is that it's not that these words, these warming will only be there single times, but there it will not exist in another part. But the word between warm and warming might exist in another part. Here, let's say we go into 30 May. We go into 30 May and say we go to part 1. Okay, and we go to the last block. So you can see the words starting with W are also on the part 1 and also on the part 0. Okay, but the key called wine or wind will not exist in another part. Okay, you can see had wine been there, it could have been probably uh, here, between this and this. Correct? All right. So individually, both are distinct set of keys, and also you can concatenate them. Yeah. It can be a single file provided you use a single reduce tasks. Okay. If you say reduce task, if you put one here, then it'll be a single file. All right. There are a few notes I want to discuss. First, it is okay to have no reducer at all. You can avoid, if you don't have a reducer, then the count will not happen. Whatever is coming from mapper, after getting sorted, it will get stored in the file system. That's all. Secondly, if you have no reducer, you can say that I don't want sorting. Then the role of Hadoop becomes very small. Okay, you can specifically say that I don't want sorting, which means whatever is the output coming from her mappers is directly getting stored in the output without any reducer, without any sorting. Okay, all right, are you able to hear me clearly? Okay, so it is, if you have no reducer, you don't want sorting, you can turn it off by mentioning minus d, the way we have mentioned the number of reduced tasks. You can say number of reduced tasks at 0. In this case, based on how many maps you have, how many map tasks you have, that will decide the output files. Okay, so now the number of maps is a function of number of input splits. Or how many blocks you have will dictate how many blocks you have will dictate number of input i- input number of maps. Okay, number of maps will be dictated by number of blocks you have. Now, it's a common question people tend to ask, that how do you decide upon how many reducers to use? Okay, and this will come again and again in your mind that, okay, so Abhishek's question is, if we have no reducers, then how is data merged at the end? The data will not be merged. Okay, if you have no reducer at the end, the data will not be merged, and whatever is the output of the mappers will go directly into HDFS, and there will be so many output files. Okay, all right, so total number of reducers is a sort of an arbitrary number, and is basically more of an instinct than mathematics. But still, th- here is something. So you have to choose a number between 0.95 to 1.75 multiplied by total number of tasks allowed in your cluster. How many tasks can your cluster execute parallelly multiplied by a number between 0.95 and 1.75? Based on this, so you just pick up a number between 0.95 and 1.75 and multiply it with maximum number of tasks, and that is your reducer, total number of reducers. Okay, and how do you know how many tasks are there? Generally, maximum possible task on your cluster is how many nodes are there in your cluster multiplied by how many tasks can be executed on each node. Okay, and that is maximum tasks. When you install Hadoop for the first time, when you install a node manager, the maximum tasks are two. Okay, maximum tasks are two, and therefore, when you multiply max task with total number of tasks, it will total number of nodes, then that will become the maximum tasks possible. So if you have 10 nodes in your cluster, by default, it can execute maximum tasks in parallel 20. Okay, and therefore your so you multiply 20 by a number which is you will choose between 0.95 to 1.75, and that will be your number of reducers, because number of reducers has to be specified by you. If you choose a number very small, if there is a single reducer, that means there'll be less of transport of the data, less of shuffling of the data. But if you choose, but if you have a single reducer, or if you a small reducer, your that reducer will be loaded with all kind of processing. Okay, so so that is something you need to decide whether to use whether to have a less number of reducers or more number of reducers. Okay, and that choosing that number from between 0.95 and 1.75 is something you have to do it in trial and error manner, meaning you first try 0.95 and then you try 1.75, and then figure out which one has taken less time and which one has taken more time, and choosing a number in between in the middle will give you give you the optimal results. Okay, okay, Robert's question is, what is the max task again? So if you have 10 computers, 10 nodes in your cluster, and you have installed the task tracker or node manager on all of these 10 nodes, so by default, they can all these task trackers can execute two tasks at a time. So total tasks that can be executed on your cluster is 10 into 2, right? Which is 20. So that is your max tasks possible. If you have multiple core machines, multiple processor machine, you can increase your max number of tasks you want to execute on each node by going into Ambari and saying that these are the my tasks which I want to execute parallelly on each node. That means your max tasks will increase because of that number. All right. So more reducers mean it's faster, but more framework load because there'll be too much of data shuffling. Because if you remember, we had three maps, and when there was a single reducer, there was only three data transfers transport happening. But the moment we increase the number of reducers to two, suddenly the data transport became six. Okay, and if you increase the number of reducers to 3, the data transport will become 9. So that way, the framework load increases. But the good part about increasing the reducers is that it does a kind of a load balancing. So if you have smaller parts being done by one reducer and one reducer fails, that means only one bucket has to be recomputed again instead of the whole bucket. So the chances of failure, even if there are failures happening, because multiple machines are being involved parallelly, you are able to utilize, you are able to recover from errors easily. So Dia's question is that why 0.95 to 1.7? That is something an empirical relation which few people at Yahoo coined, and it's more of an empirical. All right. All right. So we have gone through this. Now there is a common question. Is audio breaking for all? Okay. All right. There's a common question that in what circumstances we should not be using MapReduce. First, if you are happy with a single node and you have no plan of handling bigger data, then you don't require multiple nodes. Okay? If you are able to get your work done using a single machine happily and you do not foresee that your data is going to increase tremendously in in next 10 years, then there is no point of buying of basically getting it done through Hadoop. Okay, because if your work is getting done in reasonable time, that means it is going to get slowed down if you get it done through Hadoop. Okay, it's only in the cases where your work is not done in a reasonable time, then Hadoop solves your problem. Second, when the computation depends on previously computed steps. If you remember, one map gets one line. Okay, one map does not know about other line being processed by another map function. Okay, because all of them is happening in parallel. The only way they can communicate is that we launch a central service and all map functions are talking to that central service. Although a map function can contact any databases, anything it can do, but that will kill its strength of parallelization, right? Therefore, when the steps are so dependent on each other that one next step is depending on the previous step, the program cannot be parallelized so easily, meaning program cannot be executed in parts parallelly on multiple machines. Okay. The example is Fibonacci series. You remember Fibonacci series? In Fibonacci series, The next number is only computed based on previous numbers. So we cannot say that please run 0 to 5, 0 to 100 on one machine, 101 to 102, 101 to 200 on another machine. We cannot do that in case of a Fibonacci series. The reason is that we do not know what is 101th number is until 100 is finished. Second is, if you are looking for real-time response, okay, if you are looking for a real-time response, then MapReduce is not your solution. Okay, in terms of when I say real-time response for the computation, if you are looking for real-time response, then it's not the solution. You might want to go for things like Spark, Apache Spark. We will discuss it in the ninth or 10th session. Next is your algorithm depends on a shared global state. Okay. Imagine that you have to crawl the data across the globe, and before crawling, you have to check against a central service, right? So your mapper, let's say mapper is downloading, each mapper is, so imagine this. There is a big file of URL that is your input data. Your mapper is picking up one URL from this file, okay, or you can say that few subset of this URLs from this file is given to one data node, and each map function is picking up the URL and calling a downloading the data from there. But before doing so, it has to contact a central service to check if somebody else is also hitting the same website. In those kind of cases, what would happen is the mappers will become really slow because they will have to coordinate a lot. Although such kind of coordination happens, but there is a trade-off always. So you will have to evaluate critically that whether if there is a service which you are building, if it depends on a central state, okay, how is the dependency, okay, if okay, so you'll have to critically examine. So Abhishek, I think the video is audio is breaking only for you. Okay. All right. So in these circumstances, you do not. Okay. So Nitin's point is that I should explain the shared global state again. So let me explain this way again. So if your map function need to coordinate with other maps, or there is some database against which each map has to check the values. Okay. So every time before generating key value, it has to call a API which will connect, maybe make a REST call, or maybe call a database and then find out whether to, I mean, find out something, do some logic by calling that. So if all the mappers will start calling your shared global state for each record in the input, for each record, your mapper function is going to get called. And if your mapper is hitting some website, now imagine that all the data nodes parallelly, whichever data nodes are executing your mapper function, it is going to make so many calls to the shared global state, maybe database. Shared global state could be a database, could be any other service like Zookeeper, it could be any other, say, a website. So if that starts happening, then shared global state, the server which is managing the shared global state, has to be really robust and has to be really fast. Otherwise, what would happen is your mapper function is getting slowed down because it's making call to shared global state, and your shared global state is being hit simultaneously by all the data nodes. Make sense to you, Nitin? Yeah. So this is clear, right? The limitations of MapReduce is clear. Great. All right, so I think we all are on the same page. I hope I'm not sounding one of your typical professors where I've forgotten that where are my students, or maybe my students have gone to sleep. All right. Okay. Okay. So, yep. Yeah. Okay, so I'm happy that at least few people are awake. Great. Great. So, all right. Now, so this is clear, right? Also, as a thumb rule on testing, and testing should be part of your I mean anywhere anywhere you start coding or start developing anything, you should build a way to testing. If you remember the way I was demonstrating you just now, as I was writing my sed command, I was quickly testing it and then writing it, correct? So your development, whenever you are developing a program, that you should always have your testing plan very clear. You should not try to write once and then test once. No, you should incrementally test it. Also, a general strategy which I personally like very much, that before I start developing a bigger algorithm, I write something like a test case. So test case becomes my guiding factor while I'm building something. So in the beginning, my all the test cases fail, and slowly the percentage keeps on decreasing, and that gives me a great satisfaction. Okay, so test driven development, TDD, what Nitin says, that should be part of your life, and it should be part of your, you know, mm, any development program. Not because of any other reasons, because of having a frustration free life for a developer, or for any, even at the program management level, at the product management level, you will find your life really frustration free if you figure out, first, test as you go. Second, have a test case first, and then start building things. Okay. I'm not advocating code quality or anything here. I'm talking mostly from a developer's perspective, because developers' life become extremely frustrating if they write a lot of code and then they try to run. And that's where I have even started liking the programming languages such as Python, where you can test each statement independently before you merge them together to make the full program. Okay, that will make your building the product fun rather than the normal core. All right, so here are few thumb rules. So first, try to test your program on small data. You should always figure out, the way I have figured out that I can say echo and run my command, you should also have a small data in place so that you can quickly test whatever logic you are trying. Second, so the other strategy is that whenever we are dealing with big data, other mistake almost everybody makes is they do a tail or they do a head. Meaning, tail means the last 10 lines and head means the first 10 lines from the big data. And that's a typical mistake. Reason being, when you are going to run your program, there are very high chances that whatever you coded would be stupid, because these, when you deal with unstructured data, first lines or the last lines are the ones which you don't need to, which will be very different from actual data. Okay, and therefore a random sample of data is something very much required, and almost every tool has started to give the random sample of the data. Okay, next is separately test your mapper and reducer. Okay. Good part about mapper reducer is both can be separately tested. Okay. The way we tested our first individual commands, and then we tested mycmd.sh, and we also tested yesterday about unique minus c. Okay. All right. So that is how you basically test mapper and reducer separately. And once you have tested the mapper and reducer separately, you can, and in case you are using the streaming job, you can use the Unix command line like this. You can say cat input file, my mapper, sort, my reducer, and output file. All right. This way, this way you can, without using Hadoop, you will be able to test your mapper and reducer. Make sense to you? You want me to show you this one? So whatever I wrote just now, I can say, so find dot my name big.txt. Okay, so I can say big.txt, whatever we just did, big.txt dot mycmd.sh, and then pass it to sort, and then pass it to unique minus c, and then we are putting extra command called more to see the result space wise. This will do exactly what Hadoop did. You can see that. All right. The only so we are so here the sort command is doing what Hadoop did for you. So we can use this kind of a command to test your data separately. Also, you can always test this this separately, and then prepare a sorted list and test these two things eh, separately. Reducer. Okay. Now, testing a streaming job is far more simpler, but in case of Java provides something called MR unit, which lets you test mapper and reducer independently on the local machine. Okay, so it's basically MR unit provides a Hadoop emulator locally, which runs your mapper and reducer on top of data and gives you the results locally just for testing purpose. Next is how do you test predictions? Because mostly when you will be using these big data tools, you might be using it for predictions. So this is a interesting question. Can somebody answer this fifth one? Yeah. How to test predictions? Let's say you are building some program which will give the predictions of future, or you are writing a movie recommender based on the past history of the users. You are giving recommendation on movies. That this person would you would like these movies because you have liked those movies. Okay, or you are writing something like another recommender like Amazon, that people who bought this also will buy this. Correct. Thank you, Abhishek Verma. So basically the way we do is we do the past data analysis. The way if somebody comes around and tells you that, hey, I'll tell your future, you tell me, you ask him that, can you tell my past first? And if it is successfully able to tell your past, then you can rely on them that they might tell the future correctly. Okay. So what you do is, let's say, let's say there was There was 1 million records, okay, containing user ID and the movie they liked and the ratings they gave. Okay, this is a little important, so I'm taking a little bit more time here. Okay, so you have one user, you have this kind of a format, some user ID, some movie, some rating. Now, based on this, you are giving recommendations that this user will like something. So what you will do is you will split this data. You'll split this data into 500k sets. Okay, two 500k sets. Based on first 500k, you will generate recommendation and then check these recommendations against the rest of the data. Okay, so based on the first set, you will generate the recommendation and then you will compare those recommendations against remaining. Okay, and the way you will split this data will be based on the timeline. Meaning, if your recommender has run only on the date we had 500,000 records, whatever recommendation it gave, did it actually happen? Okay, based on timeline, you split the data and say up to 2005 we have the records. Now we will do the prediction and then compare with the rest of the data after 2005 till 2015, that you were predicting, your program is predicting something in 2005. Did it really happen afterwards? So that's a kind of, when you have, okay, when you have the, you have to test predictions. Okay, you split the data into two parts. Okay, you split the data, split into two parts chronologically, compare predictions based on first set against, okay, compare predictions generated, or let me first generate generate predictions on first set, compare the predictions against second set. Make sense to all of you? Although it's a common sense, but we all forget it. Okay, great. All right. So now here is our first assignment. What I have already told you, that code your MR problems in your any favorite language, whether English or any other programming language. Second problem for today is, based on the content from a large text archive, formulate the next word's recommendation. Okay. So you have got a huge text. You have got, say, 1 terabyte of text. Now all you want to do is go through this terabyte of text and prepare the recommendation such that when user types one word, you have to give you have to give 5 words what user can type. Okay, all right. You can download the Wikipedia's data from this place. Yes. No, not Google style. Google style will be far more difficult to do. This one is very simple. Here the prediction is just based on single word, based on the word you first word you type, not the whole phrase. All right, because if you try to do with the whole phrase, then it will be fairly difficult. So happy birthday, happy new year, happy marriage. Based on the text, you can figure out a pattern. What are the words that are occurring after a word? And then you build this kind of a recommendation. Okay. So now, so there are, just go through this document. It says that you have a direct link to Wikipedia, and then there will be a way to download it. I think they have changed it now. Okay. Okay, let me figure out a better way to download, or maybe there'll be a way to download the text from Wikipedia. Okay, all right, great. So I need to see what you also have a look at it. Basically, the idea is to download whole Wikipedia in plain text. Okay, and then run it, or I- or maybe just take the big.txt file and try to build your algorithm based on big.txt file. And once it is working fine, you can go with a bigger project like this. Okay, looks like this GitHub one will also do. We'll have to just figure out. But for time being, what you can do is just take big.txt, which is lying in asgiri input, asgiri word count input folder, and try to build your recommender based on that. All right. Clearly put down your assumptions when you are building next five because there will be many kind of assumptions you can make. All right. All right. So everybody is up with these things. So I need to remove this. I can remove that. All right. All right. So let me start with the next session. Okay. My machine is for some reason very slow. Let me pause everything. Oh, thank you for reminding that. I completely forgot. Okay, let's take a break. Let's take a break for 10 minutes. Back by 10:16 p.m. IST. So, should we start now? Okay, so here we are. All right, so should we have this discussion now regarding the problem which we just stated? Did you think about a solution? Yes. We'll not go too much of detail into actual implementation. We'll talk about general strategy, and then actual implementation you can go ahead and do it. Okay. So, all right. So how would you do it? How would you do it? What will your mapper do and what will your reducer do? Can somebody tell me? So Robert says map will give out word I to word I plus one. Okay. So word ith will be the word key and word I plus one will be the value. And next time the output would be word I plus one and word I plus two. Correct? All right. Anybody else? So this way we are basically saying for each word we are making the key and the next word to each word is the value. Effectively, all the words that are following a single word will become the value when it reaches to the reducer. And then in the reducer, we can do the top five by finding the frequency of the word. Correct. That's correct, Abhishek. Great, great. So, yes. So, this is the approach we are going to take. So in the mapper, our map function is going to be called on each line at a time, and we and mapper is going to break down the line into words and give out each word and its next word as the each word as the key and its next word as the value. For example, in this case, we have how are you. So mapper will generate how are you. And in case of Ram, happy birthday, that's the next line. So it'll become Ram happy birthday to you, you happy, and happy new. And then in case of year, because in the fourth line there is nothing else and there is only a single word, we don't print anything. Make sense to you? And then we do the frequency analysis, meaning we gather because the first word, how, for example, is the key. All the words that are following how will be in the value when it goes to the reducer. And therefore reducer can compute what are the top five words. So do you see any problems in this? No problems, do you see? Correct. Special handling for the last sentence. Joining of the two different sentence might give you unwanted results. That's correct. Anything else? Do you see a problem here? Anything else? I see a one more problem. Can somebody point that problem out? Intermediate words of sentences should be handled cautiously. Okay. Robert says lower and uppercase. Okay. Yes, that is another problem. And the special words and all that. Yeah. Anything else do you see here? Any problem? So we talked about three things so far. First, the line should be broken based on sentences, not based on new line. Correct? Correct. Here, the way the lines are broken are based on new line character. Ideally, they should be broken based on maybe dot, dot space. Okay. So the problem statement, Robert, is very clear. We have to give our user, while the user is typing happy, all the five words, top five recommendations we have to display to the end user. That's the only thing we have to do. Okay. And for that, we need to prepare this list that after a particular word, after a particular words, what are the five words which are following it? Okay. So, all right. So you don't see any other problem with this approach. First one was that the sentence kind of problems, because if the sentence did not end, we we have to handle those cases. Second was the upper cases. Yeah. No, the problem statement is that we have to give the recommendation to the user, right? Now, when the user types RAM here, we should not be giving a recommendation of happy, because that does not make sense. Correct? And we have to take care of those cases. Although you might argue that these cases are rare, and hence when do the frequency analysis, these cases will be removed. Correct? All right. So yeah, there wouldn't be any much of a, but here based on this data, there wouldn't be any recommendation for RAM. But if there is too much of data, RAM has been doing this, so we can give is and have based on the whole data. All right. Good. Good. Any other recommendation? Any other problem do you see with this kind of problem? With this kind of a solution? Good. So Abhishek is saying that how to deal with a situation if how are you goes to another mapper than Ram. Correct. Correct. And that's exactly the scenario here, right? One line went to one map function, another line went to another map function, and hence the trouble which we are facing right now. Okay. All right. There are one more problem which I foresee. All right, let me break the suspense. So first is the second problem and third problem you have already figured out. That last word of the line should pair with the first word of the next line if the sentence has not ended. Okay? The last word of a sentence should not be paired. Okay? These are the two problems. Third problem is computation of frequency can be further map reduced. Right? Now imagine this. If you have prepositions like is, am, are, the values that follow is, they will be millions. Correct? There will be millions of words that follow is. Therefore, for a key called is, values will be so many that your reducer will be swamped. Your reducer will go into will have to compute that frequency using multiple machine rather than single machine, and that has to be properly done. Okay, so there are multiple techniques for that. I'll give you the time to think about these problems, and we will discuss the second and third problem today. All right. So, okay, so computation of frequency can be here. Like the problem is, imagine that there is a word like is. There's a word like is. So almost every sentence has a word like is, which means for word is, there are too many values. For a key called is, there will be too many values, right? Is this, is that, is x, is y, and so on. So for the words which are very commonly occurring, the values will be so many that a single reducer has to handle them, right? Your reducer function, as we told you, that all the values for a key always go to single machine. They are not parallelized, they are not distributed. Therefore, your reducer, whichever is computing that frequency, whichever is finding the top five most frequent word, it has to do a lot of work on a single machine. Make sense, Abhishek? Nitin? For those words which are very frequently occurring, meaning there are so many words that follow is of the almost every word has the before it. So imagine values of the word the will be millions, right? In case of a text, and handling that is too much of will be, if it goes to a single machine, it is going to get swamped. Just think about an alternate solution. If you think about a little bit more, you can come up with your strategy that how should our map give out the key value, and then you will be able to solve this problem. I- Okay, I'm very confident that you guys will be able to solve it, and I leave that problem to all of you to come up with a strategy to handle first, while I'll explain to you how to solve the second and third problem. All right? All right, a little recap. A little recap. So that quickly, so the data generated by mapper is given to reducer and then it's sorted or shuffled. Yes or no? Okay, I'm reading it again. So data generated by mapper is given to reducer and after that it is sorted. Is that correct or wrong? Correct. That is correct, Vikas. Thank you. It is sorted in map as well as while merging at before reducer, it is sorted again. As in it's a kind of a merge and sort together in reducer. All right. Great. So everybody says no. All right. Great. So the output of the mapper is first shuffled and sorted, and then the reducers are called. Great. Great. All right, so all of you are agreeing with me. Now, The mapper can only generate a single key value pair for an input value. True or false? The mapper can only generate a single key value pair for an input. Brilliant. All right, great. So this class is actually this this batch is actually pretty smart because most of us in the previous session said true in this case. So false. Yes. So mapper can generate as many key value pair as it wants for the input. Okay. Now next question is mapper have to generate at least one key value pair for input. Is that correct or wrong? So put correct or wrong because I will not confuse with the previous one. Mapper has always have to generate at least one key value pair, correct or wrong? Great, great. So wrong, brilliant, brilliant. So almost everybody is agreeing. Yes, I think everybody is agreeing. I'm moving to the next question. By default, there is only one reducer in case of streaming job. When we do not specify number of reducer, how many reducers were chosen? In our first example, if you remember, how many files were there in the first example and when we did not specify number of reducers? So by default, there is only one reducer. Correct. So initially, there was only one reducer when we did not specify number of reducers. Because if you remember, when we ran it for the first time, it only gave a single file, right? Great, great. Yes, by default, there is a single reducer job, but it can be split by using the command line, but it can be it can be in number of reducers can be increased by specifying this particular variable. Okay. Number of reducers in case of Java map reduce are dynamically decided. All right. What is the map role of a job tracker? Brilliant. All right. A map logic is preferably on the nodes that have required data, yes or no. Map logic is executed preferably on the nodes that have the needed data. All right. A little bit of a strategic question here. Great, great. Everyone is agreeing with us. Brilliant, brilliant. So the map logic is always is the keyword here, is always executed on the nodes that have required data. Meaning, in case in case there is no nodes available having the required data, the map will fail. It will not execute if the same node on which data was there, if same node is not available for processing, it will give an error. Brilliant, brilliant. All right, so it's wrong. Everybody is agreeing with me. All right, great, great. Yeah. So question is, map logic is always executed on the here. So it's not necessary that let's imagine that there was one node containing your data. Okay, the data node was there on that one particular node. So your data was on data node A, which is humongously busy, and you want to churn this data. Okay, now should Hadoop give you a error that that node in which the data is available is not available for processing, or it should execute on some nearby node? So Hadoop chooses to execute in on nearby node, and the data gets transferred over the network on the nearby node. Okay, make sense? All right. Now, where does Hadoop store the result of reducer? In HDFS or in local machine? Great. All right, it is in HDFS. Now next is, all right, next is that next question point is that where does Hadoop store the intermediate data such as output of map tasks? So on each machine your mapper is running, is generating key values, and Hadoop is receiving those key values, and will it store those key values on the local machine, or will it push it to the HDFS? So it is little tricky question, all right? So pay a little more attention. So if it is in memory, what would happen is, if it is in memory, if the data is really big, what would happen? Because each block is going to be 128 MB. If there are many tasks running, will it consume that much memory? That's correct. Because good, good. Yes. So the way it works is, first data is received in the memory, and parallelly, as the data is being read from your mapper function by Hadoop, it's being moved into the disk parallelly. Okay. Okay. So all of you are correct in a way that first the data goes into memory, and then it purges into the local file system. All right. It's like the way I'm typing here, and once I'm done, I'm pressing Control S and saving it into the disk. Okay, that's how it's also doing. It's receiving your key value and then saving it into the disk. Make sense to you? Good. Now, next question is, this is a little difficult question. So, the whole of the HDFS block available on a node is fed to the mapper. Meaning, if there is 128 bytes available, will that full 128 bytes will be given to the mapper node? Will be given to your mapper task, or only part of it will be given to your mapper task? Anyone? Okay. Which part, Aruna and Nitin? and Seth? Yeah. My mouse is frozen, so I'm not sure if I'll be able to. I think I'll have to do something about it. I'll have to do something about it. My keyboard and mouse has stopped working, and what exactly is going on with this machine? Can somebody end the meeting or something? I'm not able to get the control of the machine. Finally, it's working. Yeah. All right. So finally, it is working. Thank God I had to. So let me just stop the recording and start the recording again, because if this problem occurs again, then the recording might go away. All right. All right. So are you able to hear me? All right. Good, good. So Vikas is correct in this sense. So no, the whole file is not provided to your mapper. If you remember that the way we were giving the data to our input to the mapper was line by line. So imagine this, half of the line is on one machine and half of the line is on another machine. So feeding half of line to one mapper will not make any sense. Therefore, first this remaining half is generally transferred to the other node and then fed to the your mapper code. Okay. So basically now here lies the difference. In HDFS block is your raw data. And to your mapper function, we are expecting. All right, just give me a minute. All right, so is okay. All right, so we'll go into the more details of it just now. Just give me 2 minutes and we'll discuss it more. Okay. So I'm not sure. All right, no worries. So I will discuss this input split. So basically, blocks contains the raw data, and we load the raw data using a logical construct called input split, and that input split is what we did, which decides what is it that is going to go into your mapper. So based on input split, the data is fed to your mapper. Okay, so we'll go into more details in a minute. All right. Okay, so first, before that, we will like to go with MapReduce in Java. How do you do MapReduce in Java? One is that writing MapReduce in Java is beneficial because Java is the one in which the Hadoop has been written. So it's easier to control Hadoop using Java. Okay. And second is there is a primary support in Hadoop. Therefore, it is generally a little bit faster to get your work done in Java. Okay. So, but main reason is this. Okay. We can modify the behavior of Hadoop. We can customize the behavior of Hadoop to a very large extent using Java. Okay. Now, to to start working on Java in for MapReduce, you have to first install Eclipse. If you have not never installed Eclipse before, you can go to eclipse.org, download any one. Okay, download any Eclipse, and then okay, search for Eclipse, download any Eclipse version, and then create a Java project, and then add all the libraries provided. A easier thing to would be import the project provided. Yeah. So Nitin is saying it's even easier to use Maven. Yeah, that's also possible because Maven will help you downloading the dependencies. Okay. So I will better write here to do. Let me make a note of it. Maven command to download the dependencies. Okay, I'll put that somewhere. All right, thank you. And yeah. All right, so let me just show you the steps. So I've already created the project and created this skeleton. You can better download the project and import that. Okay, so let me close it and I'll show you the. So here you can see that there is a project. You can create your own project using new, or you can simply say import the project. Okay, existing project, and after you have downloaded the project mentioned, say whatever project I've uploaded into that, you can import it. It will give you this kind of a thing. Okay, good, good. All right, and then you can start working on this. Okay, now coming back to so writing Java code is a little bit more verbose. So and it looked little awkward to the people who have not worked on Java, but the people who have worked on Java will find it very comforting, like Nitin. Yeah. So okay, going back to so you can go to No Big Data, My Courses, session number 4, and there you will see the session number 4, and there you will see you'll see the sample project. You can download this project and import. So yeah, we will be using Hadoop 2. Do not use Hadoop 1. Nobody uses Hadoop 1 anymore. Okay. So are you having issues, Aruna, on Windows 64-bit? Just send me the screenshot. Maybe I can help. All right. So to begin with, you can import the project available on the session number 4. You download this, unzip it, and then you can import it, and then you will have something of this sort. Okay. So that's a easier way to kickstart rather than writing. So first of all, we will understand. So after you have created a blank project, the first file you generally create is a mapper, a blank mapper probably. And there, the definition of the blank mapper goes like public class, your mapper name, you can give any name you want. Extend, you'll have to mention that it extends something called a mapper class. And you have to also mention here what is the data type of input and output. So first one is the input key object, which is input keys data type is object, and value is okay. Inputs input line, basically this is the input data. These two is the data type for the input for mapper, and the second part is the data type of the output to the of the mapper. All right. So here you can see now, we always talked about so far that in our mapper we get a single line as input. So we partially lied. We did not tell you that you also get something called a byte offset. Instead of a line number, you get something called a byte offset. Byte offset means this line is starting at byte, which byte, okay? Which character in the whole file rather than the line number, okay? All right, is the voice breaking? All right, let me see what happens. All right, so is it better now or is it still breaking? Okay, thank you. All right, so so first thing is that what is the various data types which mapper is receiving and what is the data type mapper is giving out. Okay, the key value is what you have to specify. Then this is the function you need to write, and whatever data types you have specified, those are the data types you have to mention here. Okay, the key will be of the data type object because you have declared here. Value will be of the type text because that's what you have declared here, and the context will be an object provided to you. So in your stub mapper, the map function will receive a key and the value and a context. You receive three things from Hadoop. And inside this map function, you will write your logic. Here, our logic says value.toString, meaning convert the value into toString, split it by tab or space, and that way you will get an array of words. You iterate over these array of words and write that output into the context. Okay, so let me try to so, so is that okay if we try to restart? I think I'll just restart the router probably, and that should probably work. Can you believe this? Session might disconnect for some time. Alright, this is awkward. All right. So, are you able to hear me, or is it still breaking? Am I audible to you? Are you able to hear me now? All right, great. All right, so we were discussing before getting stuck with the network problems. So yeah, we were discussing about how do you write a mapper. Okay, so before you write a mapper, you basically first say that first create a class with whatever name you want to create, and then extend a mapper, and then you define what is the input data type and output data type. Okay, okay, and whatever data type you specify for input and output, you have to mention the same thing here also. Along with that, there is one interesting object called context. And this context object carries does a lot of things for you. First and foremost things, this is the object which will collect key and values from you. Meaning the key and the values you will have to write into context. You will say context.write, here is my key and here is my value. Okay. Now new text is like a wrapper over your actual word, because you cannot give a normal string to Hadoop because they have their own different data types. So you have to basically box it like a gift wrap it, with, say, if it's a string, you have to gift wrap it into text. Okay. And if it's a number, it's an integer or a long, you might have to write long writable or int writable. You have to cast it, you have to convert it, or you have to box it, meaning put it into a box called long writable and then give it to context.write. Okay? You cannot give it just like that. So that's a little bit of a syntax thing. So I'll show you how does it look actually. So this is how it looks actually. So it does a little bit more things. So we are creating a stub mapper, extends mapper. It has to be a public class. It cannot be a private class. And then you have this. Okay. And then we have map object here. All right. Like this. So is it clear to you? How would you write your mapper? Great. Great. So essentially what am I doing here is I am basically splitting it by space or tab and then iterating over the words, removing everything which is non-alphanumeric, okay, and then converting the word into lowercase and then doing that. All right. Next thing I would do is create the reducer, and in the reducer, in the same way, you have to define what is the input key value. What are the output key values, meaning the data types of input key and input value and output key and output value? And the same thing here. So in reduce, you will get key and the values. In the reducer, you will get key and the values. All right. So the data type of this value is basically an iterable containing long writable, whatever data type you have defined. And also note that whatever is the input data types of reducer will be the same as the output data types of the mapper. You can see that it's text long writable and here it's text long writable. Okay, and inside reducer you see the you are given key and the list of values.
Okay, you're given key and list of values, and these values, you iterate over these values, and whatever is the summation of this, you put it again in the context. Okay, instead of printing it, you put it in the context. If you are printing something here saying using your usual sys.out, that all of those statements, those print statement, debug statements, or log statements, all of those statements will go into the logs, and you can look at those logs using that interface which we have shown you. The URL, that interface will be available on the URL which is given out by the MapReduce when it starts. So this is your reducer. Makes sense to you? Now you have written your mapper and you have written your reducer. Now third thing you need to do is tie them together. Tie mapper and reducer together. Okay? By writing something called a driver. Driver is your entry point. Driver is the entry point, which means it has the main method. Main method is the one which gets executed when your program boots. And so step driver will be your entry point. All right. And inside this step driver, what all you have, first you create a job and you set a jar by class name. Okay. You can set a class name for the jar, and these are all mostly optional things. Then this is important, the one which is in bold. Here we are telling that my mapper is this and my reducer is this, and afterwards we are also specifying data types, overall data types for our MapReduce jobs, although it's fairly optional. Now we need to provide the input data to our mapper reducer. We provide that using something called add input path. Okay, to the job we are adding input directories, and here the input path is whatever we are providing as argument to our program. So arg0 is the argument provided to our program. Okay, arg0 is the data which is provided as the argument to our main function, which means our command line argument to our program. Okay, so and then we have the output path, place where we are going to write the data to, that we need to specify in the job. So effectively, job is the object which contains all the information about what we are trying to execute. Job knows our mapper, job knows our reducer, job knows our input folder, job knows our output folder, and so on. Okay, and once this is done, once you're done with configuring, you say job wait for completion, meaning start executing and we will wait for its completion. And that's pretty much that you require at the driver level. Okay, you can see here we have stub driver, and step driver contains all these things. Here you can ignore these part for some time. So you can also specify how many reduce tasks you want to execute, number of reducers you want. Okay, sounds good to you? All right. You can also ignore for this the other values. All right. Now, once you have done writing such kind of a code, what you can do is you export a jar. You could say export. Okay, Nitin, you can go into in the session 4. If you go into my courses, do you see session 4? My courses, and then you click on Hadoop, and then will you do you see session 4? And under session 4, there will be two projects. Pick up the first one, import that into Eclipse, then you will have this. Whatever error occurs, whatever errors are occurring, you look at those errors and try to fix those. Mostly will be related to the Java path. Okay. And also, I forgot to explain to you this part. So while installing you can install Eclipse, create a Java project or import the Java project and change the JDK to 7.0. Why? Why? Because the output which we require here. Okay. So generally, when you are compiling your product, it should be compatible with lowest possible JVM. Okay, specifically the Java output setting should be maybe 1.6 or lower. Reason being that if you are compiling your product which is compatible with 1.5 or 1.6, it should be able to run on almost every data center. So whenever you are shipping your product, not only with respect to Hadoop, you always, but in general, you always compile your product for a very lower version of Java. Okay. So here I'm using, okay, you can see that. So here Java compiler, we can specify that this is our compliance level, meaning our program will be able to run on Java 1.6, Java 1.7, Java 1.8. Okay, Java 6, Java 7, Java 8. So that is how it is designed. Now, yes, okay. So yeah, all right. Now once you're done with writing this, let's just say file. We can select the project and say file, export, and we select the jar, and then we select our project, and then say right here the location of our my mapper, and we call it say 30 May. All right. So now it is done. It is done on my local machine. Now let me copy it. So this is my local machine. This is my local machine. From here, I'm going to, so I copied the data and exported it using this file. So I'm saying scp, the file name, and then we say student at hadoop1.nobigdata.com colon asgiri. Okay. So I'm copying this particular jar which I just created onto student at hadoop1.nobigdata.com. Okay. So it's copied. Now here, all right. So I go into my folder. It must be there somewhere. Okay. So you can see it is there. All right. All right. Nitin, you can send me an email. I can send it out to you. All right. So I think I have a latest version. I can send out the latest version to you. Okay, all right. So sure, sure. I'll send it to everyone. Okay. So we have this, and we can say Hadoop jar, and we run our program. So it says that we please provide the main class name. And what is our main class name? Our main class name is step driver, and step driver is existing in a package called sg. So we can say sg.stepdriver. Now it will ask us, it will say it 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 has given us this error where it says that if our argument is not provided, give this error. Okay, so this is coming from our program. All right, now we can provide our input folder word, word count slash input. Okay, asgiri slash word count slash output 30 May, and I put J along with that. Now it should start processing the data. Okay, all right. So it has started running our code, and let's have a look at what's going on with the job. Okay, so it says that it's running it on the same set of data, and it says that there are two reducers. Why are there two reducers? Anyone? Correct. We had specified it here. Great. So everybody is paying attention. I'm pretty happy. Now, so okay, all right. Now, also a few things I wanted to show it to you. Here, there is something called logs. It can show you the various kinds of logs. Along with this, if you go into your process, say mapper, and here you go into the task. So under these logs, you will find everything which your program has given on stdout or std error. Okay, if your program has written printf everywhere, those things will come here. I'm talking in context with the Java developers. So if you are saying system.out.println, all of that will come here. If you say system.error.println, it will come here. Okay, just like the way it has come here. Okay, so that way you can debug your program. You can understand what's going on. Any print statement you are putting in the map function, it is going to be printed here. Also, please note that this is a full-fledged Java program, which means it can connect to a database. It can it can make a socket connection. It can make it can make remote process call. It can do almost everything a Java program can do. All right. Okay. So the way I'm running it is mentioned here also. Okay. So I'm running it Hadoop. Let me copy paste it for you. So the way I was running it is this way. Okay. So I was saying Hadoop jar, my jar, and then I specified my entry point, my driver name, and then I specify the input folder and output folder. Why? Because our program expects, our driver is expecting the arguments in the program. All right. So it's okay, Nitin. You can write to everybody. I think your setting is to only organizers. All right. All right. So one more thing I wanted to show you is that you can write your stub test. Okay. Have a look at the stub test. Basically, we are creating a dummy map reduce driver here. Okay. These dummy map reduce driver run my map reduce code just like that. Okay. So I've just written a very rudimentary test case where there is a test map reduce, and all it does is it creates some dummy input data and then runs my word count program. So let me try to run this one also. I can say run as and say JUnit test. Okay. So you can see that this test case has failed because I have written there fail this test case. This test case has passed. It is written that this is fail. Sorry, this one has also failed. And this one will pass because I have written assert equals. If I add one more word and I don't increase this, it will fail. Okay. So basically the way I've written my test map reduce, you should write test map and test reducer separately as well. Okay, that way you will be able to compute the map reduce test cases. Okay, also it has computed the word count using our mapper reducer. You can see it here. Okay, locally also. So we have a look at the test cases, how I have written the test cases, and write the proper test cases, and also share with me. If you are creating a GitHub project, please go ahead and share that GitHub project for me with me so that I can review it. All right. Next is that in case you are using third-party libraries, okay. So Nitin's question is where my Java code will reside to run against a Hadoop cluster. So your Java code will first be on the local, on the Hadoop one local, not in the HDFS. Then the moment you say Hadoop jar, this jar will be cached onto the cluster. Okay, the jar will be copied onto the cluster. Something called there is a big good name for it. It's called distributed cache. Distributed cache is a place where you put the data and then that whole data is made available to all the data nodes, all the task trackers. Okay, all the task trackers can access the distributed cache. So every library or every code, whichever is to be shared to all the nodes, first has to be put into the distributed cache. Now, the other thing is when you use minus use lib, if you have a dependency on third-party libraries, then you can use minus use lib and your library gets copied onto the distributed cache and made available on all the machines. Okay, okay, but all right, so that's pretty much. We will discuss everything after this on the next session. Okay, we have written the test cases, we have gone through the test cases. All right, we will discuss everything from here in the next session. All right, have a good day. No worries. All right, let me save the chat and then It'll be okay if you learn Java, but streaming is powerful enough. Okay, have a look at the documentation of a streaming job. That is powerful enough, and you can do wonders with that. All right. Thank you very much. No, this will be good enough. There is a manual link to the Hadoop streaming. Go through that manual also. That will give you the more details about Hadoop streaming. All right. All right. Thank you very much. I'll have to hang up now. Have a great week ahead. Bye bye.